Today's lesson, lesson 66, we'll be talking about the formulas for systems of equations. In tomorrow's lesson, we'll do our continuation of lesson 66, talking about our phase shift as well as our period changes. Now, back in lesson 62, we had gone over some different kinds of systems, and those were dealing with things that had abstract coefficients. So we were able to develop some formulas back then. So we solved our linear system that had those abstract coefficients, and we'll walk back through those here today so we can remember what did those equations look like, because the answers for those equations are the formulas that we'll be using here today from lesson 66. So I can use that formula that we're going to come up with to solve any kind of linear system in our lesson today. So remember, a linear system, that's just a system where you have no exponents. Your equations just contain an x and a y. The first thing that we had done back in lesson 62 was we had looked at the following abstract equation, and we had come up with a formula for x. Now, if my job was to take this system and solve it for x, that means I would have to get rid of the y. What do I need to do to get rid of the y? Because they're currently not opposites, we had to multiply. So the top equation, we had to multiply it by b2 because that's what the second equation had. And the second equation, we had to multiply by negative b1. The first equation had a b1 and the second equation didn't. Now remember, that one had to be a negative b1 because we needed opposites on our two equations. After I multiply through by my opposites, here's the two equations that you now come up with. The equations for the y's have opposites, so those two are able to cancel out. We were combining the other two columns together for the x's as well as for the constants that we have on the right side. Now for the x's, those two terms are not alike. So we just had to do a1b2x minus a2b1x was equal to, and again on the right side, those aren't like terms, so b2c1 minus b1c2. If our job was to solve for x, we noted that the x was inside of both of those terms on the left-hand side, so we factored it out to the front. We pulled out our common factor. To finish getting the x by itself, we divided that parenthesis over to the right side of the equation, and it gave us the following answer. b2c1 minus b1c2 all over a1b2 minus a2b1. That's what we did back in lesson 62. Now we're going to take that answer and see how do we correctly apply it to our formulas or to our systems to come up with an actual numerical answer. So in your notebook, please make sure you write down the following formula. You're going to be using this formula if the question wants you to solve for x, and it's the answer that we just came up with. b2c1 minus b1c2 all over a1b2 minus a2b1. Now, you might be wondering what on earth do those A, B, and C stand for? Well, the A will be the first coefficient that you see in the question. It's the coefficient of your x. The B is the second coefficient in your question. It's in front of the letter y. The C is going to be the constant in each one of your equations. The numbers 1 and 2 that you see in the formula refer to the first equation or the second equation, and we'll look at that as we're working through our example. That formula is not something that you need to worry about memorizing. I'll go ahead and give it to you anytime that we're going to use it on a quiz or on a test. So let's look at the following system. Our job is to solve 3x plus 2y is equal to 8, and then 4x plus 5y equals 3. We're supposed to solve that for x. Now, we've looked at a number of methods as to how to solve these systems of equations before, like our substitution, our Cramer's rule, our graphing, our elimination. So today's is just another method that we can use to solve a system of equations. What's nice about the method that we're going to talk about today is if your system gives you a fraction answer, which these ones are, you don't want to put a fraction answer back into your system to come up with the other answer in your question. So what did my formula for x say? It says b2c1 minus b1c2 all over a1b2 minus a2b1. So let's fill that in. In our question, what is the b2? So again, b is the coefficient of the y, and it came from the second equation, which is the 5, times c1. C is the constant, and it's 1, so of the first equation, which was the 8. And then minus b1, the b from the first equation is the number 2, times c2, the constant from the second equation is the number 3. Filling in the denominator, a1, b2. So the a from the first equation is the coefficient of the x, which is the number 3. b2, the b from the second equation is your 5. minus A2, the A from the second equation, is your number 4, times B1, the B from the first equation, is the number 2. Now, doing the multiplication first, we're just going to follow our order of operations. So I got 40 minus 6 all over 15 minus 8. Subtract is your next step. So I get 34 over 7. Now, 34 over 7 is a fraction that doesn't reduce. We're going to go ahead and stop and leave it there as an improper fraction. Don't turn it into a decimal. Now, notice this is why I don't want to use like our main method of elimination, because if I had to do elimination, I would then take this answer for x and put it back into either of those systems to find the answer for y. Well, we could do that, but that's going to be a whole lot of mess for us to work with. So these formulas are making it easier for us to come up with the answers to our two different systems for the system that we're going to look for x and y. Now, we just noticed that we had a formula for x. So let's go ahead and look at how do we correctly develop the formula for y. Then we'll actually go back and do the exact same system and solve that one for y. If my job is to solve for y, that means I need to get rid of the x. So the first equation is going to have to be multiplied by a2, because that's what the second equation has in front of the x. And the second equation will have to get multiplied by negative a1. The a1, because that's what the first equation has, and then negative, so I have my opposites. Here's what my two equations now look like once I do my multiplication process. Notice the x's now have opposites, so they can cancel each other out. Just like we saw on the x work, when I go to put the y pieces together, those aren't like terms, so I can't actually subtract them. So I just had to write a2b1y minus a1b2y, and then the same thing on the right side of the equation. I can't actually subtract those. The y is part of both of those terms on the left side of the question, so I'm able to factor it out to the front. Once I factor it out to the front, we're going to divide, and there's our answer for the y that we had in our question. That formula is going to help us now as we move to our system to come up with the answer for y. Let's go ahead and mark that formula down in our notebook here. The formula for y says a1c2 minus a2c1 over a1b2 minus a2b1. Now, you may notice that's actually not the exact same formula that we just came up with on the previous slide. It's the same pieces in the numerator and the denominator, but they're backwards. The reason we want to do that is for the formulas for x and for y, we want the two denominators to be the same. a1b2 minus a2b1 was the denominator for the x. So all I did was I took the work that we just did on the previous slide and I changed the signs of every single piece that was in the fraction. I'm allowed to do that because technically I'm multiplying the top by -1 and the bottom by -1, so I was consistent with what I did on the entire fraction. Let's take this formula and go back to our system that we just looked at for x to see if we can correctly solve for y. So my formula for y says a1. I took the a from the first equation, which was the 3, times c2. The constant in the second equation is also the number 3, minus a2, that was our 4, times c1, 8. All over, and notice the denominator is the exact same thing we saw for x. So 3 times 5 minus 4 times 2. Multiply first, so 9 minus 32 over 15 minus 8, and that gives us negative 23 over 7. Again, if I had solved for y first using our elimination method, I would have had to substitute this answer back in to solve for x. It is possible, but that's a lot of extra work that we don't want to go about doing in our question. So make sure you have your formulas written down for your x and for your y. Be careful on any homework questions, like if it says minus 2y on that top equation, that you'd be using a negative 2 when you would go to fill in the B1 on your question.